everybody, today we're going to look at a lesson on what's called the empirical rule. So kind of going forward, we're going to try to use our statistics to help predict things or make assumptions. So the first one is kind of the most basic. It's called the empirical rule, and we'll talk about some specific percentages that we can use. But to start, this is just a quick definition because you'll see this word a lot. So a normal distribution is a distribution that is symmetrical and follows a bell-shaped pattern. Okay, so literally that means like the shape of the bell, okay, the top of a bell. So you don't have to draw the bottom of the bell, but your data, if it's normal, is going to follow this pattern right here. Okay, and then you can see how that's symmetrical. You have the same on both sides there. Okay, so this is the most commonly seen or used type of distribution in statistics. If you do your samples correctly, which we'll learn about in 2 lessons, it should create this type of distribution if you're doing any sort of surveying or sampling or anything like that. Okay, so we will see lots of normal distributions as we learn about sampling and create data sets. So which of the following data sets looks approximately normal? So usually I'd have us go through and actually calculate some statistics, but can't really do that outside of class. So I'm going to just show you what the pictures look like. So for it to be approximately normal, it should follow this shape right here. So these are dot plots, and I usually just like to draw along the top of the dot plot. Okay, and that one looks pretty bell-shaped. None of these are going to be perfect because nothing is perfect in real life, but you want to see if it approximately follows that shape right there. Okay, so that one does look bell-shaped. So it is normal. That's a normal distribution. Okay, this one, if I follow this curve, okay, it almost looks like half of a bell. So this is not bell-shaped or not normal. Okay, so we wouldn't be able to use what's called this empirical rule below. So when it's asking for is it normal, if they give you the data point or the dot plot, you can just kind of draw along the top to see if it has that normal distribution. Same thing if they give you like a histogram or a bar graph, just kind of follow, draw along the top, see if it has that bell shape. Okay, so some specific property of normal distributions. So if it's normal, the mean and the median are going to be approximately equal because they're both going to be located in the middle of the data set. Okay, so the median is always in the middle because you line them up, find the middle. But if the mean is in the middle, that means it has that good symmetric property where it's kind of equal to underneath it as it is going above it. So it's symmetric, however much is above it is also below it. So if it's normal, your mean and your median should be actually about at the same spot. The curve is approximately symmetrical. Okay, and then most of the data is going to be clustered around your mean. Okay, so if you look at this picture, you can see a lot of the data points are really, really close to the mean here, and then as I get further out, there's less and less data points. Okay, so any type of like standardized test you've ever taken, like SAT, ACT, one of your EOCs, they always want their scores to follow this bell-shaped curve, okay, where you kind of have an average where most people score around, and then fewer people get really, really high grades, and fewer people get really, really low grades. So you can see most of your data should be around that average. Okay, so if your data is approximately normal, okay, you can use what's called the empirical rule, and we can actually put percentages to most of the data. So we're going to calculate how much of the data is within 1 standard deviation, 2, and 3 standard deviations. And this is one you just have to memorize, that if it is approximately normal, it's going to follow this pattern. So approximately 68% of the data is within 1 standard deviation. Okay, so if you go 1 standard deviation out both ways, okay, it's going to have almost 70% of your data. If you go out 2 standard deviations both ways, it's going to have 95% of your data. Okay, so that goes out a little bit further. But if you go out 3 standard deviations, it's almost going to have all of your data. So 99.7% of the data is within 3 standard deviations of the mean. Okay, and we'll see what that looks like on this example here. For a set of data, the mean is 20 and the standard deviation is 3. It says draw a curve and find the values 1, 2, and 3 standard deviations away from the mean in both directions. So you'll see a lot of curve drawing in the next couple lessons. So what you want to do is just draw kind of an approximately normal. You want to put your mean in the middle. So our mean is 20. And then we're going to go out 1, 2, and 3 standard deviations from this mean. Okay, and what I mean is that we're going to add and we're going to subtract the standard deviation. Okay, so if I go out 1 standard deviation, that means I'm going to add 3, okay, to go this way, which puts me at 23. And then I would subtract 3 to go this way, which puts me at 17. Okay, so that's 1 standard deviation. And then we'll go out another standard deviation to get 2. So add another 3, that puts me at 26. Subtract another 3, that puts me at 14. Okay, and then add another 3, I'm at 29. Subtract 3, I'm at 11. Okay, so you're just using that standard deviation to add and subtract. Okay, so 68% of the data is between what two values? So it would be within 1 standard deviation. So here's my mean. If I go 1 standard deviation out, okay, it's going to be between 17 and 23. Okay, 95% is within 2 standard deviations, so I go out 1 more. That puts me at 14 and 26. And then 99.7 is within 3 standard deviations, so those are those last numbers, 11 and 29. Okay, so that's our basic empirical rule where you can just kind of go out, add your standard deviation, and subtract your standard deviation, and you'll see the 68, 95, 99.7. Okay, on the second page, we're going to make that a little bit more specific. Okay, because with your percentages, since your bell-shaped curve is symmetric, you can actually split up these percentages a little bit more. So this is going to be super, super important that you write this down or you get a picture off Google. Okay, you'll see them everywhere. But this doesn't give us a lot of information and it's very specific. You want to go from here to here. That's a 1, sorry. And then we can break that down to be able to answer a little bit more questions. Okay. So it's much more useful to split up each section into a percentage so we can calculate a variety of percentages or probabilities. We're going to be using this second picture a lot, so make sure you write it down or recreate it using the 68, 95, and 99.7. Okay, a couple reminders. Remember, this symbol is your Greek mu, that means mean. And this symbol is the lowercase sigma, and that means standard deviation. Okay, so if you're looking at all these symbols, I thought that was a 3 real quick, that's why I paused, but that's a 1. So your mean's in the middle, and then it's basically saying add a standard deviation, subtract the standard deviation, add 2 standard deviations, subtract 2 standard deviations, and so on. Okay, so we're going to start with this 68%. So we know that these two sides should be symmetric. So this whole part is 68%. Okay, I can divide that in half because it should be equal on both sides. So this piece would be 34%, and this piece would be 34%. Okay, and I'm going to finish drawing these lines that didn't all show up here. Okay, because we're going to have a percentage for each little category. So we've got 68%, and then we divided that in half. So both of these are 34. Okay, our next step says from here to here is 95%. We want to figure out just these little pieces right here. So if we do 95 minus 68, okay, that means 27%, okay, has to be split between these two. So I need to do 27 divided by 2, which gives me 13.5%. So both of these, okay, or 13.5%, because they need to be equal, and then we need to add to 95. So if you add those together, you should get 95%. Okay, 3 standard deviations is 99.7. So we already have 95% right here. So 99.7 minus 95 gives me 4.7. Okay, and then I'm dividing that by 2. Because it's going to be equal on both sides. Okay, and that gives me 2.35%. Okay, so we're almost done. We do actually have to get a percentage out here. Okay, so we've got 99.7. So there's still 0.3 left because the whole curve should be 100%. So 100 minus 99.7 is 0.3. And then I need to divide that into these two pieces out here. So 0.3 divided by 2 is 0.15. Okay, so you should have a 34, 13.5, 2.35, and 0.15. So we'll be using these exact same percentages for this problem down here and for the problems on your practice. So that's why I said it's important you write these down because we're basically just copying those same ones. So you don't have to redo this every single time. Okay, so here's our second example, being able to use our empirical rule. And once you get the bell curve drawn, you're basically just going to use those percentages to answer questions. Okay, so in advanced algebra, the mean for the last chapter test was 80 with a standard deviation of 7. Assume the test scores for the subject are normally distributed. So we're going to create a bell curve, okay, with the test scores. And we're going to label our mean 1, 2, and 3 standard deviations away. And then we're going to put those percentages into this curve as well. Okay, so our mean was 80. And then we're going to use our standard deviation of 7 to go up and go down. So 80 plus 7 is 87. Plus another 7 is 94. Plus another 7 is 101. And we just need to go out 3. And then we're going to do the same thing and subtract. So 80 minus 7 is 73. Minus 7 again is 66. Minus 7 again is 59. And I'm going to draw these little lines so we can do our percentages. Okay, so we're just going to copy those same ones. So 34 and 34. 13.5, 13.5. 2.35, 2.35, and then out on the end is 0.15. Okay, so that's what you want to do every time is just figure out those numbers and then get the percentages and copy them down. And then once you have that, basically all we're doing is reading this chart. Okay, so what percent of students scored less than a 73? So here's my 73. I want to know what percent is less than that. So I just add those together. So 13.5 plus 2.35 plus 0.15. And that gives me 16%. Okay, so if there are 400 students in advanced algebra, how many students scored less than a 73? So we figured out the percent. Now it wants to know how many. So I need to use that percent, okay, to figure out how many of those students is 16% of 400. So if I do 400 times 0.16, okay, that gives me 64. So there are 64 students that scored less than a 73, okay, because it was 16% of 400. Okay, what percent of students who took the test scored above a 94? So here's 94. I want above that, so I would add 2.35 plus 0.15, and that gives me 2.5%. Okay, what percent of the students who took the test scored between 59 and 66 points? So we already have that percent, so 2.35%. Okay, and you notice I have to use these very specific data points. So if you don't see those numbers, something went wrong there. Okay, later on we'll figure out what to do if it's like in between those values. But with these, you can only use the specific data points you come up with. All right, if there are 400 advanced algebra students, how many students scored between 59 and 66 points? So we already have the percent was the 2.35. So now we need to multiply. So 400 times 0.0235, changing that to a decimal. And we get 9.4, okay, or about 9 students. So we're using these to estimate. And then the last one, I like this question because it's useful. If you've ever seen any of your test reports and they tell you you're in the 99th percentile or the 100th percentile or the 50th percentile, basically that's telling you what percent of people scored below what you did. So if you scored at 94, what percentile did you score in? Okay, so you want to say what percent is below you. Okay, so what percentage of people scored below that value? So if I scored a 94, okay, to figure out what percentile I'm in, I need to see what percent of people scored below a 94. So I need to add all of these together. So 0.15 plus 2.35 plus 13.5 plus 34 plus 34 plus 13.5. Okay, and that gives me 97.5%. So that means if you make a 94, you're in the 97.5 percentile. Okay, so if you see that question, you just add up what is below that value. All right, so there's a Google form with just 2 problems kind of like this one. So you can practice that empirical rule and use those percentages. Okay, let me know if you have any questions.